So the use of Annexin A1-binding. So can you hear? Okay. Okay. Oh no.
We can hear you.
Yeah. Okay. So use of Annexin A1-binding peptide as an orally administrable tumor vasculature targeting therapeutic. And so this is a graph of IF7 peptide. I'm sorry. IF7 peptide targeting to the tumor. IF7 peptide was screened. I'm sorry. Screened from phage, short peptide phage library by selecting as a target, because at that time we think selecting was a receptor of tumor cells, but that was wrong. But anyway, IF7 was screened. IF7 was screened. Then IF7 peptide with control IgG was targeted to the tumor. However, anti-annexin A1 antibody injected IF7 peptide did not targeted to the tumor. And then lung, liver, heart, spleen, and all representative organs were not targeted. So IF7 was look like a specific targeting molecule. And this is Jan Schnitzer's data. I don't know why, but also except Annexin A1, all the so far reported vasculature targeting molecules. I don't know why. Molecules are not specific, but Annexin A1 is a specific vasculature targeting molecule. And then IF7 Alexa 488 conjugated and green fluorescence IF7 was intravenously injected into tumor bearing mouse. The tumor was created by dorsal skin folds chamber. Then IF7 was move of IF7 was visualized by the camera and captured by film. Don't know why. And then the IF7 targeting was very fast, as you see in this slide. After 15 minutes and 30 minutes was visualized, and then after 1 minute and 2 minutes, almost plateau. As a control, To summarize that result, the normal endothelial cells does not have any annexin A1, but annexin A1 was expressed on the tumor vasculature. And we said annexin A1 N-terminal region as MC16. MC16 is the N-terminal region of annexin A1. And then the rest of annexin was, major part of annexin 1 was conserved among annexin gene families. And N-terminal region was unique to each annexin family protein. And we made a monoclonal antibody against MC16 region and then stained immunohistochemically by human tumor cells, tumor samples, prostate cancer and breast cancer and lung cancer and hepatocellular carcinoma, liver cancer, ovarian cancer, and glioblastoma. And all of the tested tumor specimen was vasculature positive of MC16 antibody. This is in vitro IF7 and MC16 binding assay. MC16 and mouse MC16 was only one amino acid different. And so, as you notice that human MC16 is a stronger binder, slightly stronger binder than mouse MC16. So that means so far I shown in the mouse data relevant to the human tumor specimen. Okay. This is mouse tumor targeting, in vitro targeting of IF7. IF7 is again labeled with Alexa 488, and then from tail vein, IF7 was injected. Then IF7 seen as punctated signal at vasculature region. And then after 40 minutes, the punctated signal was extravasated into the tumor stroma. And we are interested in the brain tumors, as brain has difficulty to chemotherapeutic treatment. And so we made a brain tumor with mouse B16 cells. Then brain tumor bearing mouse was injected through tail vein with Annexin IF7 peptide. And as you see in the slide, IF7 was targeted to the brain tumor. Control peptide was not shown did not show that kind of targeting activity. So we treated with IF7 conjugated chemotherapeutic. And as you see in this slide, vehicle only treated mouse, brain tumors bearing mouse was, tumor was increased over time, but then died. And control CRR SN38 conjugated mouse was injected through tail vein, and then very similar. There is no effect, and died. But IF7 conjugated SN38 was much lower than SN38 alone, but has significant effect. And then tumor signals was decreased than original level. So mice survived, and finally the mice was tumor free. So this is the first time I saw the significant effect. So we looked at what is lower signals effect, and then we injected LLC2, tumor cells and B16 tumor cell, and then injected in another mouse, recovered mouse, and naive mice compared. B16 was injected into naive mice. Naive mice has tumor cells. However, recovered mouse injected B16 region. This region was dead B16 cells, and many CD8 alpha staining was detected. That means cytotoxic T cell marker, cytotoxic T cell was accumulated into the B16 cells injected site. And then we looked at the possibility of orally administered peptide, and by using reverse peptide library screening, and that was first LMC16 IF7 peptide receptor was created by D-type amino acid, and then D-type amino acid was coated in a plastic plate, and then phage library that was represented in the L-type library was added. Then bind to the DMC16 was isolated. That was then converted to chemically to D-type amino acid. Oops. This is a library screening results. We basically isolated the TITW PTM peptide as a best peptide. Then we created the D-type DT7 and conjugated with geldanamycin, and then injected through brain tumor bearing mouse. D-type geldanamycin was injected, then suppressed the tumor. So I'm sorry, D-type geldanamycin conjugated peptide was administered orally. Then this peptide was not degraded and then suppressed the brain tumor. And mouse survived more than 2 weeks, and then control died, but mouse was survived more than 2 weeks. So today, summary of today's talk is MC16, or amino terminal domain of annexin 1, is specifically expressed in luminal side surface of malignant tumor vasculature, including brain tumors. IF7-SN38 target to the MC16 domain, and SN38 suppressed tumor growth. Recovered mice become resistant to the tumor. D-type peptide DTIT7 was identified by reverse phase library strategy. DTIT7 was conjugated with geldanamycin, and DTIT7 geldanamycin target to the gut to blood transfer and brain tumor. Thank you for the patience.